The science behind climate change. Climate change refers to significant and long-term shifts in Earth's climate patterns, including temperature, precipitation, and weather events. It is primarily driven by human activities that increase greenhouse gas concentrations in the atmosphere, leading to global warming and other environmental changes. Here's a detailed look at the science behind climate change. Greenhouse effect. The greenhouse effect is a natural process where certain gases in Earth's atmosphere, such as carbon dioxide, methane, and water vapor, trap heat from the sun. This trapped heat warms the planet's surface to a habitable average temperature of about 15 degrees Celsius, 59 degrees Fahrenheit. Enhanced greenhouse effect. Human activities, particularly the burning of fossil fuels, coal, oil, and natural gas, for energy, industrial processes, deforestation, and agriculture, have significantly increased the concentration of greenhouse gases in the atmosphere. This enhanced greenhouse effect intensifies the trapping of heat, leading to global warming. Greenhouse gases. Carbon dioxide, CO2, is the primary greenhouse gas emitted by human activities, accounting for about 80% of total emissions. Methane, CH4, and nitrous oxide, N2O, are also significant greenhouse gases, albeit in smaller quantities. These gases trap heat in the atmosphere and contribute to warming. Temperature trends. Scientific observations show that Earth's average surface temperature has increased by approximately 1.2 degrees Celsius, 2.2 degrees Fahrenheit, since the late 19th century. This warming trend is evident in rising global temperatures, warming oceans, melting polar ice caps, and shrinking glaciers. Impacts on weather patterns. Climate change alters weather patterns and increases the frequency and intensity of extreme weather events such as heat waves, droughts, heavy rainfall, and hurricanes. These changes have profound implications for agriculture, water resources, ecosystems, and human health. Ocean acidification. Increased levels of CO2 in the atmosphere also lead to higher concentrations of CO2 in seawater, causing ocean acidification. This process harms marine ecosystems, particularly coral reefs and shellfish, which rely on carbonate ions to build their shells and skeletons. Sea level rise. Melting glaciers and ice sheets, along with the thermal expansion of seawater due to warming, contribute to sea level rise. Rising sea levels threaten coastal communities with increased flooding, erosion, and saltwater intrusion into freshwater sources. Feedback mechanisms. Climate change triggers feedback mechanisms that amplify its effects. For example, melting Arctic ice reduces the planet's reflectivity, albedo, causing more sunlight to be absorbed by the darker ocean surface, further warming the region. Mitigation and adaptation. Addressing climate change requires both mitigation efforts to reduce greenhouse gas emissions and adaptation strategies to build resilience to its impacts. Mitigation involves transitioning to cleaner energy sources, improving energy efficiency, and adopting sustainable land use practices. Adaptation focuses on preparing communities for climate impacts and minimizing vulnerabilities. Global agreements. The Paris Agreement, adopted in 2015 by nearly 200 countries, aims to limit global warming to well below 2 degrees Celsius, 3.6 degrees Fahrenheit, above pre-industrial levels, with efforts to pursue a more ambitious target of 1.5 degrees Celsius, 2.7 degrees Fahrenheit. International cooperation is crucial for achieving these goals and addressing the global challenge of climate change. Understanding the science behind climate change is essential for informed decision-making, policy development, and collective action to mitigate its impacts and safeguard the planet's future. Continued research, innovation, and global cooperation are critical in addressing this pressing environmental issue.